So welcome all, and thank you for being here. Today we have advanced security workshop, and this is the first workshop on that. And in a couple of weeks we will have the second one. And we have David here with us who will tell you all about that. David, the floor is yours.
Great, thank you, Jorinda. Okay, welcome along, everyone. Thank you. Okay, thanks a million, guys. So as Jorinda said there, this is the first of two workshops on the advanced security product. And today what we'll be looking at is how encrypting the data can actually minimize the risk of any damage associated with a potential ransomware attack. So we have, within these Tech Lounge series of webinars, we have 4 webinars in a row on the topic of database security. So the one we did 2 weeks ago was on the database security assessment tool. So if you haven't seen that one, it is available on demand, and it's definitely worth having a look back on. So during the demo, what we'll have a look at is how to actually encrypt a tablespace, and more importantly, how unencrypted data is actually just sitting there in plain text and can be read directly from operating system files without even logging into the database. So during the live labs, we'll use, during the demo, we'll use live labs to run this, so we can walk you through how to connect into that. My colleague Smith is available in the background, so if you have any questions throughout, as Jorinda said, look, just stick them in the Q&A. You don't have to wait till the end or anything like that. Smith will be more than happy to answer all those. So let's crack on with it. So just the safe harbor statement there before we start, just to say anything in here isn't legally binding, basically. So what's going on with data security right now? So the hottest topic, without a doubt, and probably the most prevalent threat in cybersecurity is, without a doubt, ransomware. So what is ransomware? So just a very quick recap, a quick overview for anyone not fully up to speed on it. So ransomware is the type of malware, basically. So the way it works is it employs a type of encryption to hold a victim's information or data at ransom. So how would ransomware appear in your system? Well, generally it's through, like with ransomware or any malware, really, it's distributed using targeted email spam campaigns, or it could be social engineering, it could be a confidence style trick, anything like that, really. So once the ransomware drops onto the system, it executes a malicious binary on the infected system, okay? And at that stage, ransomware then is designed to spread laterally throughout the network, and it will target specifically database servers and file servers. So once the ransomware then gets to a critical system, is that the user or organization's data will generally be encrypted, okay? And at that stage, they can't access files, databases, applications, whatever's running on that server. So that can very quickly cease all operations within an entire organization. So once the files are then encrypted, ransomware would prompt the user for a ransom to be paid within 24 to 48 hours to decrypt the files. Or the threat is that they'll be leaked or lost forever. So at that stage, you've got 2 options. So one is to pay the ransom, and the second is to restore the backups. And always the recommendation is, never pay the ransom, okay? So why not? Because, well, basically you're dealing with criminals for a start, so if you're dependent on their integrity, you could be in trouble. So you might not get a decryption key. So you might pay for a decryption key, they might not give it to you. They might just keep upping the ransom. They might keep asking you for more and more money. They might send you a decryption key that kind of works, but is really, really slow, as we'll see shortly. And even if it does work out fine, there is a moral obligation with it. You're funding criminal activity. So ideally, if it is at all possible, if you are suffering a ransomware attack, the recommendation is always restore your backups. So finally, with this, just on ransomware, it is a growing threat, okay? And we'll see how much now on the next slide. So just the key statistics on it, the vital stats. 20 billion is the global cost of ransomware so far this year, okay? And that in 2015 was 325 million. And by 2030, that is predicted to grow to $265 billion. Okay, so an absolutely huge jump there in the space of 15 years. So it is a growing threat. 37% of businesses have experienced an attack, so over 1 in 3. And the average cost to recover from ransomware is $1.85 million. So again, we spoke about this in the last webinar. If you attended that, it does cost money to implement a security solution, but often that cost is going to be minuscule in comparison to the potential damage and the costs associated with a breach or a hack or an attack. So what the advice is always, don't scrimp on this, don't cut corners on security for the sake of saving money in the short term, because it could cost a whole lot more in the long run. And finally, there in 2021, it's predicted an attack will happen on an organization system every 11 seconds. So you've got a very prevalent threat, and it's growing by the day. It's an absolutely critical threat, so it really can't be taken lightly. And you have to remember, you're up against really skilled, educated, well-equipped cyber criminals. So, it is very important that your DBAs, your security staff, and your data are equipped with the right tools to protect your sensitive data. So the biggest example of a ransomware attack was the Colonial Pipeline attack. So, often, like when we're talking about cybersecurity often, or IT in general, we're often talking about just the technical aspects of a hack or an attack. But it's very important to remember, there are tangible consequences. There's real world impacts associated with these kind of things. So it's not just the server that is affected. It's not a server, a black box in a corner. There's very real world consequences here. So it affects people going about their daily business. So the Colonial Pipeline, just as a recap for anyone that doesn't know, this carries gasoline, diesel, jet fuel from Texas to New Jersey in the US. And around 45% of all fuel consumed on the east coast of the US actually arrives via that pipeline. So critical infrastructure. Their billing system was compromised, and Colonial Pipeline, what they started doing is shutting down other parts of the pipeline as a precaution. So at this stage, the attackers had stolen around 100 gig of data, and they were threatening to release the data on the internet if the ransom wasn't paid. So this, as much as anything, is the key danger. Okay, so it's not really just about locking up the system. It's the leverage of having your sensitive data and potentially leaking that. Okay, so that's how they try to get you to pay up that ransom. Okay, so you can see that highlighted in the red box there. This is a real screenshot as well from an infected system, not the Colonial one, but from a different system. So as we said, this is the leverage. This is why they tried to get you pay up, that threat of leaking your sensitive data. So hence that's why it's so critical why your data is encrypted in the first place. And we'll speak more about that shortly. But just to recap on the knock-on effects, the real-world consequences of this attack, fuel shortages happened at airports serviced by the pipeline. Flight schedules were changed temporarily. Fuel shortages began to occur at filling stations, and there was panic buying. So places like Alabama, Georgia, Florida, North and South Carolina, they all reported shortages. And in Washington, D.C., 87% of stations actually ran out of petrol, ran out of fuel. So with that as well, obviously, supply and demand, fuel prices rose to their highest in 7 years. So without a doubt, real tangible consequences for people interrupted, having their lives interrupted by this attack. And it was reported then hours later, the company actually paid the ransom of 75 Bitcoins, which was around $4.5 million at the time, in exchange for a decryption tool. Now that decryption tool actually proved so slow that the Colonial's old backups were actually used to bring the system back online. So as we say, more of a reason again not to pay that ransom ideally. Okay, so how to defend against ransomware? Well, this isn't an in-depth ransomware webinar, okay? So just remember what we're talking about here is how encryption can minimize the damage associated with a breach, okay? So first off, do the basics, okay? So don't be browsing dodgy websites, don't open phishing mails, be very conscious of social engineering, ensure your software is patched. Unpatched vulnerabilities are often a backdoor into your system. So all of that stuff is really basic, okay? That's your basic security hygiene. And it does sound quite tedious, but it is the most important, the most critical way of preventing these attacks from happening. And beyond that, beyond those initial basics, from Oracle's perspective, we recommend a layered approach. Okay, there's three key aspects to it. So first up is the concept of consolidation. Okay, so we have performance and security optimized hardware solutions like Exadata, and these are ideal consolidation platforms. So you could run multiple databases, multiple workloads here, and the key idea is it's much easier to protect one server than it is to protect multiple VMs or multiple servers sprawled out across an enterprise. So consolidation, less is more. You know, it's much easier to defend one fort than multiple ones. Next up is encryption. And what goes hand in hand with that, of course, is encryption key management. And of course, look, it's very important to state this isn't going to prevent an attack, but it will limit the damage if one does happen. And finally, given how prevalent the attacks actually are and how difficult they are to stop, you absolutely have to have a contingency plan in place. Okay, so if we do suffer an attack and our systems are encrypted, can we get back up and running? Can we restore our systems? Because we're absolutely not paying that ransom, okay? So our zero data loss recovery appliance, that's the optimized solution there for storing immutable backups. Because the nature of ransomware will be that it will also try to take out your backups. So it will spread laterally across your network, and it will try to also knock out your backups. So if you've got the backups just stored locally or just even on another server that they're copied to, chances are they're going to be taken out and encrypted too. Okay, so at that stage, you're left with no choice but to pay the ransom. Okay, so ZDLRA, that can help stop that from happening, and it can help get you back up and running very quickly. But for today, this is what we're speaking about, encryption. Okay, so by encrypting our data and by protecting the encryption keys, it removes that leverage that the attackers have on us. So if they have our sensitive data and it's unencrypted prior to the ransomware attack, they'll threaten to leak it, and they will leak it. Okay, so you saw that in the note on the previous slide, and now your sensitive data is out there. Okay, and you could face a huge fine because of that. Okay, so if you were at the last session, you would have seen those numbers. Marriott Hotel fined for data breach, $18 million. British Airways, $20 million. So by ensuring that the data is encrypted and that the master encryption key is stored off of that server, then it prevents that from happening. Because what can they release at that stage except an encrypted set of data files, you know, which without the encryption key is no good to anyone. Okay, so that's the key concept that we're trying to get across today. So the attack might happen, but we've minimized the risk of collateral damage and sensitive data leak by combining TDE and Key Vault. So that's the concept of it. So let's look at some of the technology involved in that concept that we just spoke about. So first up is Oracle's advanced security product. So in advanced security, we've got two key strands. Okay, so there's data redaction and transparent data encryption. So redaction, what that will basically do is dynamically mask data on the fly. Okay, so it'll stop what a non-privileged user can see. It won't alter the underlying data though. Now we look at this in much more detail in the next webinar. So for today, we're concentrating on transparent data encryption, TDE. So what TDE will do is encrypt the data on disk. So in data files, in backups, in exports. And as we touched on last week, or in the last webinar 2 weeks ago, given how critical data is now, data security can't be an afterthought. Okay, it needs to be proactively done and implemented. And it's not a nice to have. You know, this is a must have. So for TDE, unless we're encrypting the data, as we said, and as we'll see in the demo that we'll do afterwards, unless we're encrypting it, the data is just sitting there unencrypted. And unencrypted data is stored on disk, in backups, in exports, in plain text. So anyone acting maliciously can easily just read all of that data from the database without even logging into the database. They just run one command at the operating system level, and they view all of the sensitive data in the database. Okay, and we will see that in greater detail in the demo. So security regulations then, they demand that compliance is met in terms of data should be encrypted and sensitive data should not be visible to non-privileged users. And, you know, advanced security product that ticks both of those boxes very firmly. And all of this needs to be done with minimal disruption. Okay, so we need to be easily able to encrypt our data with minimal performance overhead to ensure that the system runs smoothly and our productivity isn't affected. So TDE, advanced security, will do all of that with minimal performance overhead. So this is the flow of it here. So with TDE, the user, without TDE, the user sends a request via the application, it retrieves it back from the database. And as we say, unless we're encrypting it, it's just sitting there in plain text, okay? So now we go and encrypt that data. So we have options there. We can encrypt just columns, or we could encrypt an entire table space. And always the recommendation would be encrypt an entire table space. So now we've encrypted the data on disk, in backups, in exports, wherever, okay? So we're bringing a huge level of protection now. And obviously, no longer can the files be read in plain text, okay? And it's going to do that with minimal performance overhead. So we don't need to make any changes to the application either, this is a key thing. There's minimal disruption. We'll see this in the demo. It's easy to implement for both existing unencrypted table spaces or any new table spaces that we're creating. So the bottom line with this and with any security product, we're talking about increased compliance, reduced data breaches. Okay, we saw it last week or the last webinar. You have to buy a license to use this feature, absolutely. But the average cost of a data breach in the United States is over $8 million. So the cost of putting in a security solution like this is a fraction of a percentage point compared to that. Okay, so you're reducing your risk and leaving yourself less open to a potentially massive fine. So some of the technical considerations, these are some of the encryption algorithms that are supported. And a key point to note there is from version 12.2 of the database, if you have an unencrypted table space, you can actually encrypt it online. Okay, so you're not needing to take the database offline or anything like that. You can do all that online. Now, obviously, when you're doing that, there will be a performance hit, definitely. So what we would recommend is doing that during a quieter period of time. For PDBs, isolated key store will be available from October with the next patch set of 19C. So that'll be free for everyone with Enterprise Edition also. So another critical concept is the key architecture. So with encryption, you're always going to have a master key that's used to encrypt the data encryption keys. So there's a very important decision to be made as to where to store the key. So essentially, you've got two choices. So first up, you can store the master key in a wallet locally on the server. Now, the issue with leaving the wallet on the server is, it's the equivalent of putting a lock on the front door of your house, but leaving the key underneath the doormat, okay? So while the data is encrypted, a shrewd hacker or a shrewd attacker, they're going to know where to look and they'll easily find those encryption keys and they will decrypt your data. So it totally negates, all of the encryption effort that you're going to. So for that reason, in terms of protection against ransomware, TDE alone with the local wallet, that's not going to be a viable solution or a damage limitation solution. So ideally, we need the encryption keys protected in an independent location. So we've got a product called Oracle Key Vault, which is basically a centralized repository to manage all of our encryption keys. And that's going to be a much more secure mechanism to store your encryption keys. And we look at Key Vault now in a little bit more detail. So this is very high level overview on Key Vault. Key Vault could get its own webinar, no problem. So just to give you a quick overview on that. So Key Vault, what's it going to do? It's going to be the most secure, resilient, and compliant mechanism to store things like encryption keys, SSH keys, wallets, anything that you need to keep safe and secure. Okay, and as well as that, there's going to be options in terms of high availability, redundancy. So you don't want to store all your keys on one server, have that server go offline and everything goes with it. Okay, so ideally you'd have another node running or a redundant node. You could even set up a Key Vault cluster. So there are options like that in terms of high availability. And this here is just some examples of the many use cases of Key Vault. So as you can see, look, it's not just TDE keys stored here, okay? This is an enterprise-wide solution. It's a multi-purpose tool. It'll easily integrate with any Oracle configuration, so single instance, rack, data guard, Golden Gate, whatever, okay? But beyond that, it can even integrate with things like MongoDB, MySQL, okay? So there's a huge amount of use cases there. So really just a summary, okay, just a recap on this. So we've looked at both TDE and Key Vault. So back to the crux of the issue with ransomware. So essentially, look, there's every chance you will suffer an attack given how prevalent they are. So as we said, look, do all the basic security things, okay? Do your patching. Don't be clicking the funny looking links. Be conscious, you know, a prince with a fortune probably hasn't picked you as the heir to that. So, you know, ignore that phishing mail and do all of that stuff. But even at that, it can be very, very difficult to stop these attacks. So we do have to have a contingency plan in place. So we spoke about zero data loss recovery appliance as well, okay? But we do need to minimize the potential damage from the attack. So we saw in the file sent from the hackers, the key threat from them is that they leak your sensitive data. So we need to minimize the damage, okay? So encrypt your data, okay? So ensure that if they do have access to your files, that what they have is encrypted, okay? But as we saw, that's not going to be any use to you if you're having your master encryption key stored locally on the server, okay? So they just easily decrypt that and they'll leak your data. So to prevent against that, securely store that master key in Oracle Key Vault. And now in that case, even in the event of an attack, your sensitive data is encrypted, and without the encryption keys, it's no use to anyone. They can't really leak that, okay? So that's how we're minimizing the damage associated with a ransomware attack. Just before we move on to the demo, just a couple of real-world scenarios, real-world customers that are using these products, just to show it's not purely conceptual stuff. So the first one there, the Spanish Ministry of Justice, they have a centralized system and several regional systems, and everything needs to copy into the centralized system. So they were able to comply with data privacy laws using advanced security. So they were able to encrypt over 400 million pieces of citizens' personal information. So things like first name, last name, lawsuits, court cases, arrests. And you can see in the quote there from the customer, we selected Oracle because we know its security solutions work flawlessly. Oracle solutions are an investment in peace of mind and security. And just one more, NOS, they were facing a tight schedule to comply with GDPR, and hundreds of systems were going to be affected there to rework. So for them, the best fit was a holistic approach with a suite of various Oracle security solutions. So hopefully that gives you a good foundation and a good starting point, and we'll try and tie all of that in together now with the demo. Okay, so for the demo, as we said, we're going to use Oracle Live Labs, and you can feel free to follow along with me, or you can do it afterwards. We'll have this done in time, you know, with an hour to go in the allotted time. So you will have time for yourselves to work on it, and myself and Smita will be available here in the background to help you out if you have any troubleshooting requirements. So let's hop over to Live Labs now. Just bear with me. Okay. So this is Oracle Live Labs. So when you do come into it, look, there's a ton of different workshops, and if you haven't used this before, really recommend that you do look through it. There's lots of different ones. So for today, we'll be looking at just TDE. Okay, so you can hit in here, just type in TDE in the search bar. There's other ways to search for it as well, but let's just go with this. So you'll be launching it here, and you can reserve the workshop on Live Labs then, okay? And it will run through, there'll be some prerequisite steps that need to be done to get that up and running. Now, I've already done that today, so I won't need to do that right now. So I'll just connect directly into the lab that I've configured. Now, one thing in the lab that you'll see, so for the encryption that we'll be doing, and it goes against what we just recommended in the presentation, but we will be using a local wallet just for the sake of ease of the demo. But as always, in a real world scenario, the recommendation will be to use Oracle Key Vault. Now, there is actually a Key Vault demo in here too. If you want to use that at any stage, just type OKV in there, and you can use that, and it's a really quick one too. So well worth looking at. So I've connected in. Live Labs is really easy to follow. Just read through all the notes. Steps are broken down quite well. There's some scripts that you'll need to run on the server to get everything up and running in terms of the database and all the other tiers, the web tiers, etc. But you'll be able to follow that, and all the scripts are available there for you. So for now, we'll crack on, because there are some sections. The initialization section takes about 10 minutes. So rather than us sitting here waiting for that to run, I have done all that stuff this morning. So here we are, connecting into the server. I hope you can all see that. Make it a little bit bigger. Okay. So let's have a look at what we're going to do in the lab. Okay, so essentially it's a case, we're going to create a key store and an auto login wallet for encryption keys first of all. So again, this first part is configuring that local wallet so that we can then go and encrypt our table spaces. Okay, we'll run a query before we encrypt the table spaces, and we'll show you how you can just basically read all of the data in plain text, even directly from the operating system. Okay, so once we then encrypt that table space, we'll rerun the same command and we'll show you that the sensitive data is no longer visible in plain text. Okay, we'll set a configuration then to encrypt all future newly created table spaces as well. So let's crack on with it. So at this stage, we'll need to create directories on the operating system, first of all, for the key store. So there are pre-made scripts on here. I'm just going to run them, but feel free to open them up and even take them down and copy those scripts back for yourselves if you like. You're more than welcome to. If you do plan on doing this stuff, all of the scripts are available here and all of the commands for everything that you need to be able to do. So we'll set the we'll create, as we said, the directories on the operating system for the wallet. We'll then set database parameters. Now that'll require a restart to take effect. So let's do all of that here now. So just bear with me for 1 second. Where are we? Okay. So the first one here, just to create the operating system directory. So let's have a quick look at the script. So there you can see, just pretty easy make directory ones. Okay, so let's run that. And that's done. Okay, next script then is going to set the parameters for us in the database. So again, let's have a quick look at it. Now I'm just going to fly through these really quickly, but when you get a chance, when you open up the live labs yourselves, spend a bit more time looking through these scripts. But here you can see, look, it does the restart of the database here. It changes the configuration parameters in there also. Okay, so let's just run that. That'll take a second to restart the database. Now, when the database comes back up, you'll see the modified parameter for us. Okay, so you'll see in here it's outputting the parameter configuration settings. Okay, so let's have a look at that. Now, after that comes up, then we'll actually go and create the wallet. Okay, and you'll see the result will go from not available to open but no master key. Okay, so just bear with me for 1 second till that comes back up. Okay, so that's back up. So let's have a look at this. So this is the script to actually go and create the wallet. Okay. So that's basically it here, creating the key store for the container database and creating it for the pluggable databases. So let's run that. And as we said, look, it'll switch from not available to open, but no master key. So that obviously leads us on to creating the master key, okay, at that stage. So you'll see the status will change here again. So let's create the master encryption key. So let's have a look at the script again here. So there you go, administer key management, set key using tag. There you go. So that's creating the master encryption key for us. Okay, so it's done that in the container database now. It hasn't done it in the pluggable databases yet. We'll just do it for PDB1. So same script, just appending the PDB name. So there you go. So that's open now too. Okay, so let's have a very quick look at the wallet contents, both on the operating system and within the database. Okay, so nothing too important there. So what we'll do is you'll be asked within the live lab to create an auto login wallet. Okay, so basically we'll then just rerun these commands here, and we'll see there's a very, very slight difference. So let's have a look at the command to create the auto login wallet. So there you go, administer key management, create auto login key store from key store. So all straightforward enough stuff so far. And let's rerun those scripts. So the only difference that you're going to see here at this stage is the cwallet.sso file now exists here. So that didn't exist previously. Okay, so that's all the tedious part out of the way. Okay, a little bit more interesting from here. So we're going to look at encrypting existing table spaces. So first off, so at the moment, no table spaces are encrypted. Okay, so we might have, as we spoke about in the DBSAT webinar, you might have a huge level of security within the database in that, you know, users are working off the method of least privilege. They can only see data that's relevant to them, and all that's great, okay? But the issue is there's very little point in doing a ton of that great work and knocking down the database from the application perspective or restricting privileges. You know, there's no point if you're doing that if the data is just sitting there unencrypted in the data files, okay? So in that scenario, anyone who has access to the host, they can just basically read all of the data with one command. Okay, so let's have a look at that. So at this stage, mine will vary very slightly from the live labs that you'll see, just to hammer it home a little bit more. So let's log into the database. So no typo. Okay, and I'm going to connect into PDB1. So first off, we're going to create an unencrypted tablespace. So just create tablespace, give it a data file and a size. Just 100 meg will do us. It's just going to be a small one. So now we're going to create an encrypted one, and you'll see there's a very slight difference, but an absolutely critical difference in the SQL code here. So here you go. This is the only difference: encryption, encrypt. Okay. So there you go. So let's verify those settings. Let's see that one is now encrypted. So look at the DBA underscore table spaces view. So you can see all the other table spaces out of the box ones, they're all not encrypted. And the one that we just created, unencrypted underscore table space, no. Encrypted underscore TS, yes. Okay, so they're the two we've just created. So what we'll do now is create two users. Okay, so one for each table space. And obviously that'll mean one user's data is going to be encrypted and the other one isn't. Okay, we'll give them some basic privileges then as well to be able to connect in and create some objects. So let's create the unencrypted user. So we're going to call this person plain text user, and this is where their objects are going to be stored. And we'll create someone called encrypted user. Okay. Now we're going to give them some pretty basic grants just to connect in and be able to create sessions and create tables. So again, method of least privilege, not just throwing allocation rights at them, not just giving them the DBA privilege for the sake of it, just give them exactly what they need, okay? So now let's log in as each user now, okay? Create some objects. So first up, let's log in as the plain text user. Okay. So what we'll do is create a table, first of all, and then we'll populate that. So the table that we're creating is going to have, you know, things like their name, credit card number, expiry date, security code, and social security number. So obviously really sensitive data. So the table is called unencrypted sensitive data. There you go. Now let's put some data into that. Okay, so let's have a look at that. So as you can see, there's a bunch of really sensitive data in there. Okay, so that needs to be protected. Now remember, at the moment, that's in the plain text user schema, which is, and their objects are stored in an unencrypted table space. So just bear with me now. So we'll do the same for the encrypted user now next. So connect directly into the pluggable database. So same idea, same type of table, but it's just in the different schema now, okay? So same columns and everything. Let's just show you that data. So remember, this one is in the encrypted users schema, which is stored in an encrypted tablespace. Okay, so similar table, just different data in there. Okay, so just to confirm, as we said, look, we said we might have the database really well secured, and we actually do. So the two users, you'll see that they can't actually see each other's data because we haven't granted them privileges to do that. So it is a least privileged scenario. So we're logged in here as the encrypted user, and they can't directly query the unencrypted users table, and vice versa. So let's just prove that. So you'll see here, table or view does not exist. Now we know that the table does exist. If you're a DBA, you'll be painfully aware of how ambivalent that error message actually is. The view or table does exist. It's just that you don't have access to see it. Okay. So let's just show from the other side as well, just to prove their point fully. So back in as the plain text user, let's try and see that encrypted table, and we'll get the same error message here. There we go. So least privileged scenario. Now, of course, if we do log in as sys, we're going to be able to see that. So let's just show that. Just going to do a couple of log file switches. So into the pluggable database. So remember, we're in sys at the moment, and sys can obviously see everything as they have the DBA role. So they can see both of those tables there. Okay. So this is the key part. So we can't see tables that aren't in our schema unless we have the DBA privilege, and that's a good start. Okay. But watch what happens when we just query the underlying data files. So we can actually view all of the information in plain text there. So now, without even logging into the database, we have access to all of that information. So this is true even if someone gains access to the data files, backups, data pump exports, whatever the case may be. So let's see where the data files are stored. There you go. These are the two ones we're going to be interested in. Okay, so first up, let's look at this. So just one command. Let's run it directly against the unencrypted one. There you go. Okay, so we're not even logged into the database, and we can see all of that sensitive data. Okay, so there you go. That's everything from that table is available there now below. But watch what happens when we try that now against the actual encrypted one. So that's this data file, which is obviously encrypted. Watch what happens now. There you go. Can't see anything. So it's garbage. Okay, so you can't read any of that. So it's totally encrypted. So now what you've done for this one is protected the data at rest at the infrastructure level. And again, that goes for, it's not just data files, that also applies to backups and data pump exports, okay? And as you can see, look, it's really easy to do, but it is a very absolutely crucial step in terms of securing data. So as we mentioned earlier, it really helps with regulations, compliance. It's imperative that the data is encrypted, okay? So if you have a breach, if your data is stolen, as we keep saying, there's potentially a huge fine associated. So now, what are we going to do about it? So we have some unencrypted data. So, you know, how do we encrypt it? Okay, so we can encrypt it very easily, okay? And as we said in the presentation, we can actually do that online, okay? So there's no outage required. So let's have a look at that. Really simple process, okay? So let's log back into the database, sys session. Let's log into the pluggable database. Okay, so show you this command. Very easy one. So alter tablespace, unencrypted tablespace. So that's the tablespace name. Encrypted online. Now you could put in whatever your encryption methodology that you want or algorithm that you want. We've just put this in, just an example. So that's done. So it's as simple as that. So just one command there, and now your unencrypted data is encrypted. Okay, so let's prove that that was actually successful now. Okay, so unencrypted tablespace is now encrypted there. Okay, so let's have a look at it again with that strings command that we ran previously. There you go. So that's what was previously spitting out the unencrypted data. Now you can see it's totally encrypted and they can't read it. Okay, so it's a really easy procedure. All of the functionality is inbuilt. You know, this when you buy an advanced security license, there's nothing extra to install. It's just a matter of utilizing it. So you've now purchased the appropriate license. You can use it to your heart's content. Okay, but it's easy to do, but it is a crucial aspect of securing our data. So we can now set a parameter to ensure all new table spaces are going to be encrypted going forward. So let's have a look at that. Already in here. Okay, so let's have a look at that. So checking it. This one here. So this is just going to check that for us. Very easy. So you can see at the moment, so that's set to cloud only. Okay, so this is obviously the key one we're interested in. Encrypt _new_ table spaces. At the moment, it's cloud only. So we're going to change that to always. Okay, so let's have a look at the script and the commands involved in doing that. So there you go. Alter system set encrypt new table spaces to always. Set news. There you go. So let's run that script. Okay, and you can see that's changed now from cloud only to always. Okay. So what we'll do then is just to prove that, we'll create a new table space called test. Okay, and we won't specify any encryption parameters. It just does it automatically now for us. So it'll do that in the next script. So let's have a quick look at that. So there you go, create table space test. Now you saw previously when I was creating the encrypted table space that I had to plug in the word encryption. Okay, you don't have to do that now anymore, that parameter is actually set. So it's saving you that little bit of hassle. Okay, so let's run that. Okay, so as you saw in there as well, it did run a strings command against it. So just to prove whether it was encrypted or not. So created the test table in there as well and put some information into it and ran the strings command against it. And there you go, totally encrypted. Let's drop it now again. Okay, so that's pretty much it, guys. That's everything in terms of the demo. So that's just to show how easy it is to do it. But as we said, it is an absolutely vital part of the process. Okay, so hopefully you found it useful and enjoyable. Hopefully you got something out of the session. So thanks for your time this morning. All the best, guys.